Let me ask you something. Have you ever found yourself feeling unusually tense or self-conscious when you start coughing? After COVID, many of us have felt this sudden wave of fear. Sometimes, it's not just the cough itself, it's the worry. Is this just a harmless irritation, or could it be something more serious? Do you feel that sense of urgency to consult a doctor or even rush to the hospital just to be safe? This anxiety has become a shared experience for many. Now imagine if everyone went to the hospital for minor issues. Hospitals would be overwhelmed, making it hard for doctors to care for patients properly. During the COVID-19 pandemic, healthcare systems were already stretched due to both severe cases and people seeking reassurance for minor symptoms. This led to delays for those needing urgent care. Feeling cautious is normal, but this response affects the entire healthcare system. Hi there, welcome back to a new episode of Fantastic Datasets and where to find them. Today, we'll be talking about the COUGHVID Dataset, which is a crowdsourced dataset compiled for the study of large-scale cough analysis.
But let's first see what is crowdsourcing. Crowdsourcing is a powerful concept where individuals contribute small amounts of data to collectively solve large-scale problems. In the context of healthcare, imagine everyone recording and sharing their cough sounds. These recordings can be analyzed using machine learning to identify patterns, diagnose conditions, and even provide help in outbreaks of illnesses like COVID-19 or the flu.
So then, what problem does this dataset solve in a general view? If the COUGHVID dataset is used as the foundation for a machine learning model in a smartphone app, it could change cough analysis. This app would let users analyze their coughs instantly without going to a hospital. It would provide quick insights, easing the load on healthcare and helping people assess their symptoms. Now, coming on to the specifics of the dataset, every recording in the dataset contains an audio file, usually in .webm or .ogg format, along with a metadata file. The metadata includes important details such as the individual's age and gender, expert labels, and cough detection probabilities. This dataset is notable for its large size and high-quality expert annotations, making it a valuable resource for improving cough analysis. This is the structure of the dataset we are working with. Each row represents a person, identified by a unique identifier. Alongside the identifier, we have metadata fields that provide additional details. These include the person's age and gender, as well as whether they have a respiratory condition or fever or muscle pain, which are key indicators for diagnosing respiratory illnesses. The status field reflects the individual's health condition, for example, symptomatic, healthy, or diagnosed with COVID-19. Finally, the cough detected field provides a probability score, indicating the likelihood of a cough being present in the audio recording. They have used XGBoost modeling to classify whether or not a given recording contains cough sounds. This structured data not only provides a rich set of features for analysis, but also ensures the inclusion of critical health labels, enabling precise and informed machine learning modeling. The novelty lies in how these comprehensive features, combined with the dataset's size, enhance its utility for respiratory illness detection and classification. This is where the novelty of this dataset lies, the expert labels. It highlights the expert-provided labels in the dataset that enhance its usefulness for machine learning. Each recording is annotated with the following labels: quality, which indicates cough sound quality as good, okay, poor, or no cough; cough type, which labels the cough as wet or dry; congestion, which is a Boolean indicator for nasal congestion; the diagnosis, which is an assessment of the expert about the condition of the patient; and finally, severity, which is expert impression of cough severity, from pseudocough to mild, severe, or unknown. Let us now see a real example from the dataset of a cough and its cough analysis. As we can clearly hear, the dataset also classifies this cough with a 98.2% probability of having a cough. Now, let us see an example of a non-cough recording from the dataset, which can also be said as garbage recording, and its cough analysis.
So since it was just background talking noise, the dataset classifies this cough with only 0.29% probability of having a cough. So, how can we train an AI model to recognize whether an audio contains a cough or not? Well, right now, cough sound is just a sound wave like this, but we can convert this raw audio into a spectrogram using short-time Fourier transform, which is just an image representation of the audio wave frequencies. And then finally, a CNN model can learn to recognize between a cough and non-cough recording by looking at the spectrograms.
This dataset is easily reproducible as they have provided an official repository with user-friendly instructions as to how one should use the recordings to reproduce this dataset. Now, let's talk about the real-world use case of this dataset. Imagine you are in another country on your vacations, and you are concerned about a cough you have developed. Well, in this case, you would not rush to the hospital. Instead, an AI-based smartphone application would detect your cough and give you the full analysis of it. And within a matter of seconds, you would know the severity of your cough. And then you will easily take a decision whether to go to the hospital or not. Hence, reducing unnecessary burden on the healthcare system. One notable shortcoming of the dataset is that expert labels are only available for a limited number of recordings. While these labels provide high-quality annotations crucial for training accurate machine learning models, their limited availability restricts the dataset's scalability and may introduce bias if the labeled recordings are not representative of the broader dataset. With every problem, there exists a workaround. If this dataset is to be used, it can be utilized by training a machine learning model on it to detect whether or not a recording contains a cough or not. This could be useful for doctors who want to examine a bunch of coughs, but do not want to waste their time in analyzing if the audio is clean or not. You can find the dataset at Zenodo. It has all the recordings and the metadata along with the expert labels. It has Creative Commons Attribution License 4.0, meaning the records and all its files are free and publicly available to use. Well then, is this dataset fair? If you're wondering, the FAIR data principles, findable, accessible, interoperable, and reusable, ensure that data is well managed and widely usable. Data should be findable through unique identifiers and searchable repositories, and accessible via clear, standardized protocols. Finally, data should be reusable, with proper documentation, licensing, and provenance to ensure it can be applied in future research. These principles enhance transparency, reproducibility, and innovation across disciplines. To promote collaboration, it must be interoperable, meaning it can integrate with other datasets using standard formats and vocabularies. As you can see, the COUGHVID dataset is easily findable on well-reputed search engines such as Google. Since the dataset has free public license mentioned earlier, it is also accessible. Since the WebM and the OGG formats are recognizable for almost all of the modern computer systems, hence the dataset is interoperable. And we have already talked about the reusability of this dataset being high and user-friendly. Hence, this dataset is fair, voila.
In conclusion, this dataset represents a good step forward in medical data collection, particularly for respiratory health. Its ability to assist with cough screenings offers immense potential for early detection and intervention. By enabling fast and easy cough assessment during outbreaks like COVID-19, it can play a critical role in public health management.
Moreover, the dataset helps reduce the burden on hospitals by providing a tool for remote analysis, empowering individuals to assess their symptoms from home. With its potential for scalability, this approach could revolutionize how we handle respiratory illnesses, making healthcare more accessible, efficient, and proactive. That was all for today. Hope you enjoyed the video. If you like our content, please make sure to like, comment, and subscribe our YouTube channel with the bell notification turned on. Until next time, peace out.